So what we're going to do today is twofold. Number one, we're going to solve equations by completing the square, and primarily we're going to look at problems where a is not 1. So we're going to have to get rid of that a today. And number two, we're going to be rewriting equations in what's called vertex form. If you recall vertex form, so that's actually a great place to start. What is vertex form? Well, remember this. This is standard form, ax squared plus bx plus c equals your y. So this has a function. But if you recall standard form, it looks like this. Standard form says a times x minus your h squared plus your k. Before we go on, please take a moment with your neighbor. What do the a, the x, the h, and the k tell me about when we're graphing the parabola? So h and k here are the vertex. Together they are the vertex, which means the highest or the lowest point. If my parabola looks like this, then hk is right there. Now, a tells me some nice things, and it tells me a couple things. Number one, it tells you the direction. Remember, whether it opens up like this, so if it's positive, or opens downward like this if a were negative. It also tells me about width, too. If a gets closer and closer to 0, it starts to open wider like so. But as a gets really large, 10, 15, 100, it starts to get very tight. So that's what it actually, a will tell me. It tells me the way it opens, but it also tells me how it opens. Is it wide or tight? And hk is my vertex. So what we're going to do today is, also we're going to start with this standard form, and we're going to try to rewrite it here. And it's going to be crazy because it's not going to be a lot of crazy work. All we're going to do is, notice this, complete the square. We have to get a perfect square right there. So if we can complete the square here and rewrite it to look like this. We're going to solve this by completing the square. So let's refresh again. Number one, we're going to isolate the constant. We're going to divide by the a, in this case, since a is not 1. Then we're going to find the missing term and add it to both sides. We're going to factor the trinomial, take the square root, solve for x. And of course, step 7 can be mental, but we are going to do a check as well. So, solve by completing the square. So step number 1, I am going to isolate the constant. So in this case, I'm going to subtract 1 from both sides. Number 2, this is the new part that we've not done yet, but I am going to get rid of the a there, because it's not a 1, by dividing everything by a. Divide everything by a. In doing so, I get x squared plus 5x. Notice I'm going to intentionally leave myself a little bit of space right there, because I'm going to add a missing term in just a moment. Now let's take a moment and find out what our b is, or excuse me, our missing term. So the missing term, again, this can be done mentally, but I'm going to write it over here. We take the positive 5, this right here, and we're going to divide it by 2 and square it. So when you do that, you get 25 over 4. So I'm going to write that both sides of the equation. I add 25 over 4. Now it's not very clean looking on the left side. However, what's nice about the left side is we already know it's going to factor, and it's going to factor perfectly like this. But wait a tick. How do I get this first piece right here? Well, again, all you do is take the square root there, so that's going to be an x, and you take the square root of this thing. Now remember, we already have that number. It's right here. It's the 5 divided by 2. If you take the square root of 25, you get 5. Take the square root of 4, you get 2. So what looked like could have been ugly or a lot more work, turns out to get to here is very quick, because that's a perfect square, and that's a perfect square in terms of its fraction. And the right side actually cleans up pretty well because I have a common denominator already. So the numerator becomes 24. So 24 over 4, which is actually 6. So let's continue. I'm going to take the square root of both sides here. And then I get plus or minus radical 6. Plus or minus radical 6. Now remember what our last step is, and this really is the last step, is I need to subtract the fraction from both sides. So what's my final result? So what do we do? The answer is simply this. Negative 5/2 plus or minus radical 6. And let me fix that. Exact answer. This is the answer that you will commit to. Those answers there. Now let's take a moment to estimate those by plugging that into our calculator. Again, your calculator, you can just do this. This right here is negative 2.5. And then you say plus or minus the radical 6, or the plus 6. Find out what that is. Then minus the radical 6. So again, when we estimate, both of these are going to be good answers, but this is probably the most bestest answer. There's me with my good grammar. The bottom. So let's walk together through this one to see. Number one, we need to isolate the constant. So I'm going to add the 23 to both sides. But notice what we also need to get rid of on the right side. I need to move the variable over as well. So I'm going to bring down the 2x squared plus 12x is going to equal 26. Step number 2 says I need to get rid of that a. If a is not 1, divide everything by that. So x squared plus 6x equals 13. And now at this stage, I have to calculate what the missing term is. So the missing term is going to be the b over 2 squared, which is 6 over 2 squared. So quickly I see that I'm going to add 9 to both sides. Again, this part over here can be done just in your cabeza. Left side will always factor perfectly. And this one over here gives me a 22, which we see is not a perfect square. So when I do take my square root, and that should be a 3, then I'm going to say plus or minus radical 22. And now my last step, which is so nice, because I don't really have to get crazy. I don't have to keep simplifying. I don't have to split. It turns out when your answer is not nice, your simplifying is a lot easier. You actually don't have a lot of crazy work to do. All you have to do there is leave it as it is, because things don't combine. It's already using a different process, but we want to take this and we want to turn this into vertex form. Remember the value of that. Number one, this thing, if I were to graph it, it tells me a couple things already. This right here tells me the x-intercept. So if I were to graph, I do know that my x-intercept is somewhere down here at negative 9. Excuse me, my y-intercept. Change that to the y-intercept. And so that's my y-intercept, so it's down there at negative 9. It also tells me, the a in the front tells me that it is the same width as ax squared, and that it's going to open upward. So it's going to open upward at a very nice width. But I don't know anything else more than that. I don't know if my function's going to go like this. I don't know if my function's going to go like this. I don't know if my function's way down here. I don't know if it's way over here. I don't know. I only know that it touches this point right here, and it opens up. So I have an infinite number of possibilities. So if I had access to my vertex real quick, then maybe I could quickly see that. So what I'm going to do is rewrite this from standard form to vertex form. So remember what vertex form looks like. Like we said earlier, the vertex form says this. I need to have a perfect square and then two other things hanging out outside. We have an a in the front, which could be 1, and then we have a k out here, which is not necessarily this negative 9. It might be, but it doesn't have to be. The key is I need a perfect square. So what we're actually going to do is complete the square on this side and not move the 9. We're going to leave the 9 where it is, the negative 9. So how do we do that? Well, remember the key is whatever I do in math, I have to undo at the same time. So how do we do, what do I mean by that? Well, for example, here I have x plus 3 equals 7. Well, if I do something, adding minus 3 here, then I have to undo that over here. I have to keep the balance. We often say whatever I do to one side, I do to the other. But it doesn't actually have to do to the other side. Notice what I'm allowed to do here. Do you agree that x plus 0 is still x? Yeah. If you add nothing, you don't change it. So what if I said this? X minus 3 plus 3. Is that still x? Yeah. Why did I do? What does this add up to? It adds to 0. So no matter how ugly this looks, as long as I undo it, it doesn't change anything. It doesn't change the value. So here's what I'm going to end up doing. I'm going to be adding 0 to one side, but 0 is just going to look funny. It's going to be adding opposites. So it looks like I'm doing something when I'm actually adding 0. Okay, so how do I do that? So step number 1 is I'm going to consider, all right, I am going to consider this piece right here. I want to somehow turn this into a perfect square. So what do? I'm going to temporarily ignore the negative 9, okay? So it looks like this. Y equals x squared plus 10x. I'm going to leave a space there, and I'm going to leave the negative 9 out there. Now, remember, if I want this to be a perfect square right here, I have to add a special term. Well, what's that special term? You take this right here, divide it by 2, and square it. So I add 25. But wait a minute, now I'm unbalanced. Now I've magically created and added a 25 there, but I can't just do that. So I have to undo it at the same time. So notice what I'm doing over here. I'm subtracting 25. Because if you add 25 and subtract 25 to the same side, nothing happens. Nothing changes in terms of value. All right, so now what happens to this? Well, this is a perfect square, like so, and all you have to do now is simplify the stuff that's outside. So that now is going to be negative 34. And look, I'm in vertex form. So notice that completing the square can help us solve equations, but completing the square is also very helpful to putting things in a square form, even if I'm not going to go all the way through and get x by itself. So in this case, I'm just converting us from standard form to vertex form. And all I did effectively was add 0. You added nothing to the one side, and then you're able to rewrite it. And notice the mistake on A should be y equals, because it's a function, as B is good.